Hello, everyone, and welcome to our webinar on the rise of material machine co-innovation. My name is Tanachare, and I'm joined with Astha in hosting this webinar. Please feel free to drop your questions and comments in the comments section, and we will get back to you. Uh, Today, what we want to do is really answer some of the main questions that packaging industry as a whole is facing. Largely, when we talk about sustainability and all the changes it is bringing, particularly with respect to materials, the new materials tend to not do so well in the traditional machines. And all those good innovation tend to go to waste or maybe are not scaled up to the full potential. What we want to understand and maybe put a bit of light on today is why do promising packaging innovation struggle to scale? What actually separates scalable innovation from pilot projects? And what should future packaging enable, right? So this is going first in the direction of what is changing and therefore which properties might have to be focused on, right? We will dive maybe a bit more on the transition of from plastic to paper, but of course there are other aspects that we will very briefly touch, things on monomaterial packs, the challenges in the new materials with respect to sealing, shelf life, and so on. And ultimately, we will see few examples how things are being done and what should packaging value chain as a whole focus on in terms of developing new solutions to the industry. Right? But let me start with, I mean, this is well known what is happening in the world with respect to regulation. There is lots of pressure on the material. We are seeing some of the main trends that we will be speaking of today is on the paperization. So moving away from plastic towards paper. Everything, every substrate has more and more paper now, but also things like monomaterials, increasing usage of recycled PET instead of virgin PET, uh, lightweighting also, things where bottles or packs are consistently being made thinner and lightweight, which brings problem in their behaviors in the machine as they lose the strength uh, and structural rigidity of the pack. Right. We'll also talk about digital layer and how it can help in general throughout this transition. But most importantly, the core is how to help the scaling up of these new and more sustainable innovations. Yeah. I think one of the key point that was written there in the last slide is the problem is not the material, but it's maybe more about how to scale that up, right? Uh, Very quickly, we have, before coming to this, we have looked very broadly across the spectrum, uh, different materials, different formats, different kind of operation. And what we realize is the core direction of innovation is closure next systems, the redesign of that, the high speed paperization. So things like FFS, how can we achieve faster speeds? That has become a problem, and a lot of focus is going there, or rather, that's the focus of innovation, where everyone is trying to figure out novel ways, novel modifications on the machine or on the substrate to improve the speed of paper-based formats. Barrier is another major direction where we are seeing lots of innovation after analyzing the entire landscape. Machine compatible, recycled, and monomaterial, particularly in the flexibles area. Paperboard multipack systems, rPET, or better usage of rPET or better managing the properties of rPET, digital code, and automatic handling of materials. So these are the key areas, but as a whole, if we try to look deeper into that, uh, somewhere all of those things come back and are connected to this transition, where we are talking about more sustainable solution, more sustainable materials that are driving all these innovations, right? Again, going maybe one level deeper, and what we see happening in the industry is sometime, and I think again, the webinar is motivated uh, by this. That is, in the industry, a lot of new innovations come, and somewhere down the line, as they are being scaled up, they are not accepted to that level where it might have been hoped, right? We have some examples here, maybe because of they were, for example, on the example on the right, very good properties of the material, but simply just because they were so light, while empty on the line, they kept tumbling over, and it didn't work because of that. And there might have been other reasons as well, but that is one of the reasons that was cited. Also, uh, for example, in terms of FFS, where again, most of the transition is being seen, is paper-based, either because of why when the web is supplied, it buckles a lot, or in the forming tube, there's so much friction. Uh, and because it doesn't flow so well like a plastic material would, forms wrinkling, might even tear, and again, sealing related issues. So these are some of the core reasons and examples that at least we can, highlight today, that didn't scale up to the expectation, right? And on the scaling up part, if we look at all the innovations that we had analyzed and all the references that we had checked before thinking about this webinar, uh, as a common theme, these are the 8 key challenges that we observe that everyone keeps citing. So whether it's patents or suppliers talking about their equipment and essentially saying that their machines solve this problem, but somewhere we find these 8 problems are the core uh, of the challenge today, right? So while being transferred, buckling of web, or while it is being formed, wrinkling and poor tracking of the material. There's too much friction being caused by the material, mismatch within existing forming geography and tooling, geometry and tooling. So plastic can easily bend, but with paper or paper-based material, you might have to increase your radius of curvature. Narrow or unstable sealing windows, so it maybe takes a bit more time for paper-based combinations, whereas the way the machines move with plastic, that window has to be increased so that it gives a bit more time to paper to seal. Leakage at folds, again related to sealing somehow, or independently with or without sealing at the folds because of the substrate material becomes weak at the creases. It can become a problem. We talked about sealing, so moisture and batch dependent material behavior, tearing, because of course it's not as flexible or it doesn't slip as well, and speed loss as a result of all of these problems, where ultimately, uh, even if material is being formed in the right shape and right performance parameters, at a overall line level, it is not providing that productivity, that speed, right? So yeah, this is one of the key insight that we wanted to bring, where we have these 8 challenges that are being faced and discussed a lot in the industry, right? And maybe before I pass it on to Astha to give us some concrete examples of how innovation is being brought and what problems are being solved, very quickly highlighting the general direction of that, right? So we are talking about change a bit on the material side, which is materials engineered for improving productivity, for runnability, for production scenarios. One of the key goal would be to improve moisture stability for these materials. This is, of course, during the production, but also after that. How can we improve that? There is also an angle of, can moisture change the properties, and does that change so much that during production also the parameters have to be changed, right? We'll also talk about broadening the sealing window. We very briefly touched upon that earlier. And again, because the performance of material is different, there might be that modification required on the machine, or a different set of mechanisms will have to be developed in future machines that provide that extra flexibility, that extra time, without hampering the overall productivity, overall production. And friction related aspects. So, different kind of properties have to be looked at, not just friction, but it could also be, let's say, electrical properties. But again, when we look at the literature and when we talk to the people in the industry, it's largely always about friction. So we'll keep that at a higher priority. But Asap,
Yep.
would you want to take up maybe few examples here and talk about what they have done differently and what has worked so far?
Yeah, definitely. So what we actually are trying to highlight here is there are multiple levels where the changes could be done. The remediation to the scale up challenge could be done. So the first one that we are looking at is the modifications in the material itself. So it could be like on multiple levels, like there could be coatings that could modify, that could help in reducing some of the challenges, like for example the ExxonMobil and Seegwerk, they developed together a heat resistant coating for the monomaterial PE films, and that heat resistant overprint varnish helped in resolving the sticking issue that was being encountered to the sealing bars. So that is one aspect, that we apply certain coatings or sealants to the paper based or fiber based or mono materials to help in reducing the challenges. The second aspect could be modification of the materials that actually make up the paper. For instance, we if we use long and strong fresh fibers, or like the Next Plus Advanced that is being used, that is being manufactured by the Kohler paper, it is using engineered virgin fiber structure that is actually providing the mechanical strength and web stability, which is helping these materials to perform better on the existing machines. So this is one aspect or one angle that we have seen. The next that we will be seeing is how the modifications in the uh, pack geometry or the pack structure could help in resolving the scale up challenge. So Tanya, if you can take us to the next slide. Yes, so here we are discussing the second angle or second approach, that is the structural redesigning of the pack geometry itself. So for instance, we can introduce openings and load bearing features that could help in increasing the grammage of the entire pouch. So for example, using of euro holes that could help in enhancing the load bearing features, or the increasing the radii that could help in spreading the bending strain across the paper, and that will help in improving the runnability of the paper on the existing machines. Then example from GPI, like we can eliminate the thickness steps within the critical seal zones. So eliminating overlapping folds or seams within and gussets within the sealing region, they can help in creating a more uniform structure. And a more uniform structure would be easier to scale up as compared to if it is a very complicated structure with many overlapping folds. Then other examples are there, like we can create continuous rigid tray sealing flanges that will help in compensating the lower dimensional stability of the fiber trays. And lastly, the very good very good approach could be using very simple and symmetrical packs. As the example from Kohler paper states, that when we are using very symmetrical packs, it requires fewer folds, less material, and ultimately improving the runnability on the machines. So this was the second aspect. Moving on to the third one. This is altogether, see, physical trials, there are before actually launching a paper, there are multiple physical trials, there are multiple papers or multiple materials being tested. And this is a good approach, but then ultimately this is also resource intensive. It will take time, it will take effort, it will take even money to actually test multiple papers on the machines. So before actually testing the materials on the existing machines, simulation is one angle that can be explored. So for example, uh, the Maple Sim for web converting systems from MapleSoft, it helps in simulating the behavior of new paper or monomaterial monomaterials pack, on how they will actually interact with the rollers or the drivers, and how well the web handling parameters and other machine parameters will actually work. And then based on that, some of the materials could be actually eliminated at the trial stage itself. And similarly, another aspect could be learning from what actually went wrong during the trial, and then the Simplan software, this could help in actually redesigning the whole or modeling the whole setup before actual commercial scale up. So these are just two of the approaches that could be taken. There are multiple other solutions from the digital engineering aspect as well. Then finally, moving on to the fourth example, that is the machine level interventions. So when we are talking about the machine level interventions, we can talk about on multiple steps, that is forming, transportation, sealing, and then cutting or scoring. So on forming level, what we can see is that material first angle could be material specific forming shoulders. So uh, paper compatible shoulders could be developed and installed or retrofitted on the machines. That is example from Rovema, or using a low strain forming retrofit, for example, from Syntagon. So these are the some example from forming aspect. Then moving on to the transport aspect, there could be servo pre-fed unwinding that could help in maintaining the paper tension while material is being run on the machine. Or we can have active edge and seam guidance, which could be like, for instance, using ultrasonic controls to align the narrow seams while running. This is the transportation aspect. Then coming to sealing could be multiple things could be there. So the I think something that actually was is being tried and very is running up to the expectation is cold sealing. So Syntagon has a HDG pressure seal retrofit on their machine that is actually doing the cold seal, uh, like eliminating the hot sealing aspect. And then closed loop sealing control, it's like continuously monitoring the parameters and then helping in the digital control of heat, pressure, and dwell time, which is widening the narrow sealing windows without actually damaging the web in the machines. And then for the cutting, one example could be the digital controlled laser finishing. And that is example from Carville plus Lacex. This is scoring and perforation of recyclable webs using laser. And it actually improves the edge quality and design agility. So another aspect, so we discussed altogether four aspects: changes at the material level, changes on the structural design aspect of the packs, and digital approaches, like before actually going to the physical trials, we doing some simulation, and finally the fourth aspect, that is the material level interventions. So the question or the challenge with the industry players is how to balance these four approaches, or how to come up with the roadmap, like which there's nothing that only one of the approach would be sufficient. What we need is an intermix, or a uh, balanced equation coming from all these four variables. And finally, apart from the technical aspect, one underlying important aspect that comes from this topic is the partnership. So uh, the scale up challenge would not be resolved if the material players or the OE or the converters, they are acting alone. We industry has to come together to resolve these challenges. The material manufacturers and the machine manufacturers will have to work in synchronism, so that there is this better scale up of the sustainable materials. So these are some examples, like Kohler paper plus HDG. Kohler developed this Next Plus paper. It's a flexible packaging paper, and HDG developed a special pressure seed module for their RB300 horizontal machine, which was and this was specifically tested. So this was sealing approach was redesigned, and this Next Plus paper is being used on HDG machines. Similarly, Mondi and Mespac came together. They Mondi developed the functional barrier 95 or 5 paper, and Mespac tested this specific pouches on their HR230 HFFS machines. So some examples, there's other from Syntagon and Billiard Kronos coming together, and Tetra Pak and Sterlagrad coming together. So industry is already starting to come together to develop and scale up the sustainable materials. And this is, I think, one of the right this will be one of the riding factors to help resolve this challenge.
Absolutely. Uh, Ultimately, I think key learnings, and Astha already has pointed out quite a lot of them. But just to summarize, moving from designing machine for a given material to thinking more uh, of a platform, maybe thinking a bit of modularity. You might have seen some examples earlier where just a module has been changed, but just taking maybe one notch ahead and thinking of that in advance uh, to just make yourself more future ready. Uh, the focus should not only be on next generation machine. I think that's the element that we were just talking about. Uh, Proprietary material plus machine recipes. This is where again, when in the previous slide, in fact, when multiple companies are coming together, they can build this value that can go to the entire existing base and provide next life to that install base that is already out there, but also that knowledge can be used because ultimately it's the same or more or less the same base material that is being changed, right? And just using application testing to identify future machines requirement, what will be needed, and to validate, but going beyond that and thinking more in terms of performance is what I think will be needed on part of all stakeholders in the industry. But yeah, that was it for today from our side. Uh, Astha, before we close, anything from your side to conclude?
Uh, yeah, I think one thing that was under highlighted here was the simulation aspect, developments and the developments in material, machine, everything that will be there. But I think simulation is something that will help in reducing the failure rates when we are actually going to the trials. So,
Yes.
so that is
Ex-
also one thing coming together. Yeah. Thanks.
yes. Excellent. So, all right, everyone, again, thank you very much for joining us today. Uh, we will, again, as I mentioned earlier, we will get back to your questions and answer them as soon as we can. This material, as looking at the time also, we might have skipped over certain things, but the material will be available at our website, futurebridge.com. Please come, download. And of course, there is other material that you can also use. But for today, we'll bid goodbye, and thank you all again for joining.
Thank you.